To make sense of motion in our world, we will need to learn and to use a number of physics concepts. While we're doing that, it will be vital for us also to learn how to organize and to structure these concepts. If we don't develop this organization now, we might fall into the trap of accumulating a collection of seemingly disconnected ideas, which we will not be able to use easily when we need to. If you're new to learning physics, it can be hard to figure out how best to identify the most important concepts and to organize your physics thinking around them. So, we're going to be explicit about this here, right at the beginning, and make some suggestions about how to think about physics thinking in this course. First, let's talk about distinguishing between a system and its surroundings. To start, if we fix our attention on an object whose motion we are studying, we can think of that object as our system. It will be useful to think of our system as separate from everything else. To do this, we can imagine drawing a boundary around our object. Then, the everything else, which is on the other side of the boundary, can be thought of as the surroundings. Now, as our object, our system, moves, the surroundings can affect the object, and vice versa. We say that the surroundings interact with our system, and we can visualize those interactions as crossing the boundary between the system and the surroundings. Describing different types of interactions in different ways will be a major theme in this course, where sketches like these can help us keep track of different interactions that may be happening at the same time. We will also see later how to make our notion of the system more general, say by including more than one object in the system. But what we have here is good enough to take us pretty far. Finally, it's worth mentioning that the system concept cuts across many scientific and engineering disciplines, so developing this notion here may be useful to you in other contexts beyond mechanics. Let's now discuss how to identify the most important core ideas in our course. As we just mentioned, the motion we're interested in is that of our system. So it would seem we would need to be able to describe that motion and to describe specific properties of our system. As we also just mentioned, the surroundings can play a role in how our system moves through interactions with the system. What's missing here is the bridge between what we say about the system and what we say about the interactions with the surroundings. The fundamental principles of mechanics provide the bridge that links the two. Without getting into too many details now, we can say that the first example of a fundamental principle we'll encounter is Newton's second law, which links changes to the system's motion to interactions described by forces. A second fundamental principle we'll come to later links motion changes described by energy changes to interactions described by energy transfer to or from the surroundings. Don't worry if this seems a bit too abstract now. We'll return to this picture repeatedly and flesh it out more clearly with specific examples. Finally, let's chat a bit about how to think about the physics thinking in our labs, which are the centerpiece of our course. The labs are the place we have a chance to do science. One big element involves investigation, where we will typically observe motion, determine what needs to be measured, record observations on video, and, later, analyze that video to obtain motion data. A second big element of the labs involves developing explanations of our motion observations. This means we'll need to start with our motion concepts, structured around fundamental principles, and combine them with imagination and reasoning to devise models that explain and possibly predict our observations. Our models will include computer models, which may be new for you, but we'll also use models that may be more familiar, including sketches, diagrams, and mathematical relationships. There's a third element that lies between and within the other two, and that is evaluation. Evaluation means that we will compare our observations with our model explanations and predictions, and critically assess the ways in which the comparison is good or not good. This, in turn, will typically stimulate further evaluation within a given element, for example, by spurring new observations or better ways to observe, or by prompting us to develop improved explanations or better models. In all this, constructive critiques and discussion play a critical role. Here is where the social nature of doing science can be very powerful. By giving and receiving constructive feedback, we can really help each other make big improvements in our labs. So let's all try to do that. Once again, all this may seem a bit abstract right now. Again, don't worry. We'll circle back to this in context, beginning with our first lab. Before that, however, we will need to build up our motion vocabulary and introduce our first fundamental principle. That will be the subject of the next few lectures.